Okay, these notes are neutralization reactions. When an acid and a base react, a salt and water are formed. The reactants are thus neutralized. The pH of the water is 7, so the resulting solution is neutral. So here you have an example. We have hydrochloric acid. So here's our acid. Here's our base. And then we end up with sodium chloride, which is a salt. And then, of course, water. Okay, HCl will have some sort of a pH less than 7. NaOH will have a pH above 7. And then the salt and water, that salt water has a neutral pH. Now, how much acid will neutralize a particular base, or how much base will neutralize a particular acid, is dependent on three things. The molarity of the acid and the base, which is the concentration. We'll put on here concentration. The number of moles of the acid and the base, and the volume of the acid and the base. So you kind of got to consider all of that. One way to determine the concentration or molarity of the acid or a base is to do a titration reaction with a known volume and molarity of either the acid or the base, which is kind of what these calculations involve. Now, in order to calculate either the volume or the molarity of the reacting acid or base, you will need to do an acid-base titration reaction. This uses molarity, volume, and the moles by way of the number of H's and the number of OH's in the calculation. Well, here's what I mean. Normality, we're using normality here, is the molarity times the number of the H's, and that's only for an acid, okay, or the OH's for the base. You'll know the difference because the acid will have H in it and the base will have OH in it. So now to get back to the molarity, which is the M, you have to take the normality and you have to divide it by, so this one's divided by the number of H's or OH's. What is the molarity or normality of the following solutions? So the first one we have is 0.350 molar HCl. Okay, there is but one H, so it's going to be 0.350 times 1, so it's 0.350 normal HCl. Okay? Now the next one is 0.600 molar MgOH2. So there are two OH's. So this is going to be 0.600 times 2, which is a 1.20 normal MgOH2. Okay, now what is the molarity of 0.930 normal H3PO4? There are three H's, so this one is going to involve 0.930 divided by 3, which is 0.310 molar H3PO4. Okay, hopefully you guys understand that. Okay, now for acid-base titration reactions, there's an equation we have to use. And it's real similar to, you've seen this before in the gas laws, you've seen it with solutions, with dilutions, and now you're seeing it again. We're doing this in lieu of acid-base stoichiometry. It's a little bit easier, and I think you guys can handle it. We don't really need to do the stoichiometry because this kind of incorporates the stoichiometry. So it's NaVA equals NbVb, where Na is the normality of the acid, Va is the volume of the acid, then you have the normality of the base and the volume of the base. Now I'm going to give you the different equations again. So Na is equal to NbVb over Va. Va is NbVb over Na. And now we'll do the other side. Nb is NaVa over Vb. And Vb is NaVa over Nb. Real similar to your dilutions. We do M1 V1 equals M2 V2. Only we're doing N's and V's and A's and B's. Okay, so what is the concentration of H2SO4 if it takes 25 milliliters of 0.40 molar NaOH to neutralize 48.6 milliliters of H2SO4? Okay, well, let's first figure out which is the acid and which is the base. Well, H2SO4 has got to be the acid because it has H's in it. Okay? Oops. And NaOH is the base. Now it's asking for the molarity. So obviously with the NAVA equation, NAVA equals NBVB, we're dealing with normality. So we have to find the normality first, then we can go back and figure out the molarity. So once again, you have to define your variables. Na is what we're looking for. Now let's do NB and VB. Okay, so our base is 0.40 normal. Now we have 1 OH here, okay? So I'm not going to even multiply it because I don't need to, because 0.450 times 1, well, here, times 1 is 0.450 normal. And then, of course, the 25 milliliters is attached to that. So 25.0 milliliters, which means this is the H2SO4, so 48.6 milliliters. So Na equals 0.450 times 25 divided by 48.6, and we get, it's on the calculator, we get 0.231 normal. But that's not what it's asking for. It's asking for molarity. So we have to look at how many H's. There are 2 H's in H2SO4, so we're going to divide it by 2. And that gives us 0.116 molar H2SO4. Okay, hopefully you guys understand that. Okay, how many milliliters, oh good, we're looking for volume, of 3.58 molar NaOH is required to completely neutralize 125 milliliters of 4.50 molar HCl. Okay, well, let's look, see what we got here. We have our acid here and our base here. So it looks like we're looking for VB. So Na is 4.50 molar, and there's only one, oops, what am I doing plus? There's only one H, so it's times 1. So it's 4.50 normal. VA is 125 milliliters. And B is 3.58 times 1. So it's 3.58 normal. And VB is what we're looking for. So VB is 4.50 times 125 divided by 3.58. And when we do this, we get 157 milliliters of NaOH. Make sure you put down not only the unit, so it has to be the normal, so it has to be the N or the M or the milliliters or the liters, because I might use liters in some of these, as well as the substance. I don't want to just see 157 milliliters. I want to see 157 milliliters of NaOH. Okay, what is the molarity of AlOH3, or aluminum hydroxide, if it takes 65 milliliters of 1.15 molar carbonic acid to completely neutralize 135 mils of AlOH3? Okay, let's figure out which is which. So we have the base, because it's got the OH3 in it, and this is your acid. Okay, so Na 1.15 molar times 2, because there's 2 H's, so that gives us 2.30 normal. Va is 65 milliliters of it, and B is what we're looking for, and VB is 135 milliliters. So NB is 2.30 times 65, all divided by 135. 1.11 normal. Now, we want molarity, and there are 3 OHs in AlOH3, so we're going to divide it by 3. So now it's 0.370 molar aluminum hydroxide. Okay? hopefully you guys all understand this. We'll do a warm-up in class tomorrow. Actually, we'll probably first do a quiz on pH and pOH and also of the other stuff. So I guess I will see you in class tomorrow. Bye.